Hari Om. Today, let us discuss about the topic electric cells. For current to flow in a circuit, there must be some potential difference. And this potential difference is provided by an electrical cell. It is a device which provides the necessary potential difference in an electric circuit to maintain a flow of current. It consists of two electrodes and an electrolyte solution. The positive electrode is called as cathode and the negative one is called as anode. Generally, these two electrodes differ from each other in the material in which they are made up of. The material from which the electrodes are made up of are not same, and these combination of electrodes and electrolyte solution forms the so-called electric cell. This electric cell then gives rise to a potential difference which makes electrons to flow, and as a result current flows in the circuit. Before we proceed further, we should know something about EMF of a cell. EMF stands for electromotive force, and its symbol, it is denoted using the symbol capital E. So it is the work done in moving a unit positive charge in a closed circuit once. So if you take a unit positive charge and start from a point in the circuit and move it through the complete circuit once, then the work that you have to do will be the EMF of the electric cell. If you can see the diagram, in the diagram the red colored box represents an electric cell. It has two terminals, positive terminal and negative terminal. Many cells combine to form a battery. So if we take a unit positive charge and suppose we take a point P, that is the positive terminal, we start from there, we go to A, then B, then C, then D, then N, and at last return back to P. Then the work that we have to do for this much of movement, it will be the EMF of the cell. Here you should know that any circuit where you have an electric cell, then the part of the circuit outside the cell is called as outer circuit, and the part of the circuit inside the cell is called as inner circuit. As per say here, the part of the circuit from P to N through capital R. So from P to A, then B, then C, then D, then N. This much part is outside the cell, and hence this is called as outer circuit. And the part of the circuit from N to P through small r, that is the part of the cell, the part of the circuit which is inside the cell, is called as inner circuit. Alright, so if you want to calculate the EMF of a cell, take a unit positive charge, move it in the outer circuit and the inner circuit, then the work done that you have to do will be equal to the EMF of the cell. There is another term called as terminal potential difference. It is denoted by the symbol capital V. It is nearly equal to that of EMF, and both EMF and terminal potential difference have the same units, that is volts. So what is terminal potential difference? It is the work done. It is again the work done in moving a unit positive charge only through the outer circuit, that is from positive terminal of the battery or the cell to the negative terminal of the cell, but outside the cell. You can go from the point P to point N in two ways, either through capital R or through small r. If you go from P to N through capital R, that means you are moving in the outer circuit, and that is how you have to move if you want to calculate the terminal potential difference or EMF. So I hope you are able to understand the difference between EMF and terminal potential difference. Let me repeat, EMF is the work done in moving a unit positive charge through the circuit completely. But terminal potential difference, we take the same charge, that is unit positive charge, and start from positive terminal and end at negative terminal. We don't form a complete cycle here. There is another definition for EMF and terminal potential difference as well. Suppose you know that electric cell consists of two electrodes. If you calculate the potential difference of the two electrodes using a voltmeter when no current is flowing in the circuit, in that case whatever value the voltmeter will show you is the EMF of the cell. So we can say that EMF is the terminal potential difference when no current flows in the circuit. Now if in the same configuration, that is you have two electrodes and you are calculating the potential difference of the electrodes by a voltmeter, but there is some current flowing in the circuit, then in that case the value that the voltmeter will give us will be the terminal potential difference of the cell. Alright, so we have already discussed about outer circuit and inner circuit. Now let us derive a relation between E and V, that is EMF and terminal potential difference. So as we have discussed, EMF is the work done from P to N through the outer circuit plus N to P through the inner circuit. So we can write it like this: EMF is equal to work done in the outer circuit plus work done in the inner circuit. Now as you have already read, work done formula is potential difference into charge. W is equal to V into Q. So outer work done in the outer circuit will become potential difference of the outer circuit into charge, plus similarly work done in the inner circuit will become potential difference of the inner circuit into charge. So W is equal to V into Q. We are using this. Now as in the definition we have taken a unit positive charge, that means its magnitude is 1 coulomb. So if we replace Q with 1, then the Q will vanish. So our equation will become EMF is equal to V outer plus V inner. Now let's use Ohm's law. So if we go back to this diagram again, now V outer means potential difference of the outer circuit, and potential difference of the outer circuit will be current into resistance of the outer circuit. This is using Ohm's law. V is equal to IR. How much current is flowing in the outer circuit? I. What is the resistance of the outer circuit? Capital R. So V will be I into capital R, that is V outer. So V inner will be how much current is flowing in the inner circuit? I, the same current. And what is the resistance of the inner circuit? Small r. So V inner will be I into small r. So we can write this like E is equal to, that is EMF is equal to, if we replace V outer with terminal potential difference, that is V, plus V inner can be written as I into small r. So this is a very important relation. E is equal to V plus IR. And remember that the resistance that we have used here is small r. This small r is called as internal resistance of a cell. You don't attach a resistance here. The cell already has a resistance of small r. As you know that any conductor, you may take copper wire or silver wire, which are the best conductors, even these conductors have some resistance. So the material of the electric cell also has some resistance, which is called as internal resistance, and it is denoted by small r. So small r, wherever and whenever you draw the diagram for an electric cell, you must represent two electrodes, that is positive terminal, negative terminal, and internal resistance. Do not forget internal resistance. Do not forget small r. Alright? Okay, so with this, let us stop here today. We will proceed to the next part in the next video. Thank you.